Okay, this is a video I'm making on Algebra 2, Unit 4, Lesson number 8. And the title is Unknown Exponents. The learning goal is I can approximate value of unknown exponents. So let me go straight away to the first task and solving for x. So so solve each equation, be prepared to explain your reasoning. In the first case, we can In the first case, x divided by 3, so you just have to multiply 3 both sides, okay, and you get x equals 36. So that's a easy one. The next one you'll have to divide by 3, and if you divide, get x square is 4, and then you take square root both sides. But because there's a square, you have to use plus and minus square root of 4, and the answer is plus 2 as well as minus 2. The third one is x cube is 12. So that means by the definition of radical, x has to be cube root of 12, which is also same as writing 12 raised to 1/3. And the reason is if you see 12 raised to 1/3, if you multiply itself, 12 raised to 1/3 and 12 raised to 1/3. So all this will give you 12 raised to 1, because 1/3 plus 1/3 plus 1/3 is 1, and that's what you have on the right side. So x has to be. So this is another way to write the cube root. This is by definition. Then the so question so this is question number 4 is cube root of x is 12. Okay. So that means x becomes equals 12 raised to 3 by definition of exponents. So when you're done, of course, you can multiply this as 12 times 12 and figure out using your calculator. Okay, so this will give you 144, and you multiply 12. 2 fours are 8, 2 fours are 8, 2 ones are 2, and then 1, 4, 4, and 1, and you get 8, 2, 1, 7, 1728. So basically, all you do is we say, hey, this is same as x raised to 1/3, which is 12, and then you cube both sides, and then x raised to 1/3 and 12. So both sides you do cube, which is same as x raised to 1, because 1/3 of 3 is 1, and you get the same answer what I did here, 1/7. In this case, you have square root of 3 here. You just have to square both sides. So square both sides, which is same as 3x equals 12 times 12. So if you square this, you get 144. And 144 dividing by 3, you get x equals 3 divides 14 4 times. And this will be 4, and then 2 stays, so that's 24. You get 48. So if you see the last one, 3 over x, you can use invertendo. What that means is you flip both, because the variable is down, you can always do the invertendo this way, and then multiply both sides by 3, and you get this crosses out, you get x equals 3 divided by 12, which is 3 divides 3, and 3 divides 12, 1/4, and you are done. Now, can you do another way? Is 3 over x equals 12. You can use cross product. So if you use cross product this way, you get 3 times 1 is 3, and then you have 12x. 12 times x is 12x, and then you divide by, and then divide by 12. You end up getting the same answer. Let's go to the next. So this is 8.2, And in 8.2, you can see a pattern here. Here is a pattern showing trapezoids successively decompose into four similar trapezoids at each step. If you see from here to here, so you can see that this is step in the beginning, step 2, step 3, and clearly see there's a one trapezoid here. So I will just write here, there's a one here. So you can see the 1, 2, 3, 4. So this becomes 4 trapezoid. Here you can see 1, 2, 3, 4. These are the same 4 which you see here. Uh, so if I use a pink color, this trapezoid is maybe this one. Let's put it this one. So each of these trapezoid breaks into 4, right? Then from here to here, there are 4 of them. So if you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this is 16. I want you to check that from the beginning step, one step, you go this step, you have to multiply 1, 4. And if you go from here to here, so the second step, this is step number 6. So when n is 0 here, this is when n is 1, this is when n is 2. And you can see from 2 steps, if n is 2, so you're multiplying 4 itself twice, which is 4 squared. But if you want to figure out how many trapezoids are there in the next step, so from here to here, let's see 3, and n is 3. That means this this trapezoid, one trapezoid will have to multiply by 4 times 4 times 4, and that is 4 cubed, which is going to be 64. If you want to find another one when n equals 4, then we need to multiply another 4. That means we have to multiply 4 times 4 times, how many 4s? See? 4 of them. So it depends on the input is step number is 4, then you multiply the growth here, the growth factor here is 4, so it is 4 raised to 4. If you do this, which will be 256. Okay, and this is 64. I forgot to write. So this is how the question is. And let's go to answer the questions. So if n is step number, how many smallest trapezoids are there when n is 4? Which we already see. There are 60, there are 256, and we also seen how did we get there. What about when n is 10? So it means when n is 10, suppose that means you go on, and if you see n is 10, so that means I need to multiply 4 raised to, because in the beginning there was a 1 trapezoid, so 1 times 4 raised to 10. So, and that's how we can figure out what is the answer. So on your calculator, you can put this value to 56, and you end up getting 2 raised to, you can just you can figure out from the calculator. I did not calculate this, but you can always find that. Next question is, write an equation. So write an equation if, oh, so this is done. At a certain step, there are 262 those many. So that means if there are 262, 144. So write an equation to represent the relationship between the n, the step number, and the number of trapezoids in that equation. So we have seen that if 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 an n was 0, there was a 1. If n was 1, step number 1, we seen 4 trapezoid. When n is 2, there were 16, and you can see so there is a pattern there. This is 64. When n is 4, then it is 256. So this is 4 raised to 1, this is 4 raised to 2, this is 4 raised to 3, this is 4 raised to 4. And when n is, whatever the n is, so you can see for in general, for n equals n, it could be anything, it could be 4 raised to n. That's it. Now, The next question is ask, explain to your partner how you find the value of that step number. So that means, let's see, these are the total number of trapezoids, and you need to know for what. So how do you figure out what is this n? What does n stand for? And you can see this. Uh, what does it mean is how many fours do we multiply in this case? You would keep on multiplying 4 and count the number of time it takes. So this means you keep on multiplying 4 and count the number of it takes times it takes to reach that number, to reach 262,144. And you will see if you check the calculator, we can figure out that the answer to get this is 4 raised to 9 is 26144. You can also put on the decimals also. If you see this, I already did that work. So if you put on the decimals calculator, see, this is that a number of, let's see, this piece I'm using n of, we will see, since we are talking about trapezoid, so T of n, n stands for step number, and you can see the two graphs there. For the first one is the how the number of trapezoids showing in the exponential form. And the second one, I put 262,144, and you can see the answer is 9 there. For the input 9, you end up getting that. So you can always check with the calculator also by using graphing, or you can just use the regular calc to multiply 4 times 4 times 4 and see what's going on, and you get the answer. Okay, in the third task, you can see there's a petri dish there. Okay, in the petri dish, you have bacteria. What it tells us in the beginning is in the laboratory, a colony of 100 bacteria is placed in the petri dish. The population triples, that means the growth factor every hour is 3. How do you estimate the bacteria in the petri dish after 4 hours? So, so what we can, how do we figure out is first question, how do you estimate to find the population of bacteria after 4 hours? So we can easily make, if you want, we can easily do kind of understanding that in the beginning there was 1, 2, and 3, and they're asking us what is that, what number? So because it triples, the growth factor here is the B here is triples every hour. That means it is 3. So it's like every time you multiply 3, 3, and you see it's just how many 3's do you multiply. See, this is 3, 3, 3, and that's what it is asking us. So it means you are multiplying 3, 4 times. So if you want to get from the beginning, so this if this is H stands for number of hours, since the bacteria was counted, and this BH stands for number of bacteria. So you get, so the answer to get to this is, so how many threes, how many times do you multiply 3 to get? Uh, sorry. So they're asking is after 4 hours. So that means it is 3 raised to 4. And because there was, in the beginning, it was 100. So I have to multiply 100. So this actually is B of 4. And that's it. So B of 4, you can see if you work it out on the calculator, you get, I think 81, and that's how you get 8100. Second question is asking 90 minutes. Now, this is 1 hour, this is 2 hours, so 90 minutes means, so 90 minutes is also same as 90, because 1 minute is, 1 hour is 60 minutes, see? So this minutes crosses out and you get 90 divided by 60, which is 1.5. So all you do is you just have to multiply here. So some 1.5 is between here. This is going to be 1.5. So this is 3. So, so, and this one is multiplied 2. So in between we have what 3. So it's like it is. So we have this equation we can use b raised to. So b of h is you have 100 in the beginning, and then we have the growth factor is 3. So 3 raised to h, and because h is 1.5, you can plug it in over here, and you write 3 raised to 1.5, and you get the answer. So that's all it is about it. And what about half hour? Half hour will be when h is put a half. So this will be, so in the exponential function, you put 100 times half raised to 1 over half. Sorry. So here I would like to just repeat here that when h was half, so this is half. So we put b of, I want to write this one more time. So this becomes 100 times 3 raised to half, which is also same as 100 times square root of. If you use the Desmos calculator, you can see, I just try to show it right here. 400 times 3 raised to half is 173. So that's 173. So this is 173. So this completes the first question. And now let's see. The second question is asking us. See, the second question is asking. So this is one, and the second question is asking us when will the back population like B. So we want to know when is this population is 1,000. So we need to know approximate this. So where is 1,000 is. So this will be, so if this is 900 here, and this will be maybe this is 1,000. So the question is, what is this piece? See, so this so the number of hours will be between 2 and 3. So the h that we need is h is between 2 and 3. So the question is it 2.1 or 2.2, 2.3, 2.4, 2.5? And you will see even if you put 2.1, it means if I multiply 100 times, let's see here. So if I multiply 100 times 3 raised to 2.2, let's write it. So if we take 2.1, so in the beginning it was 100, so 100 times, and you put 2 raised to, 3 raised to, because the growth factor is 3, and if I put 2.1, so our goal is to get 1,000. So one is you can try to think of this, and if you see this answer, see, so let me take off this half, and I put 2.1, and it crosses 1,000. This is 1,004. So we can think of what about 2.05? That's like 900. 2.05. That is 950. If I put 6, it will be 961. If I put 7, it's 971. If I put 8, it's, and if I put 9, and there you go, almost close. So I will have to put then 2.091 or 92, 93, 94, 5, and there it is. So 2.095. So that's the answer, 2.095. So this will be the only way to get 1,000. To get 1,000, so this has to be, the exponent has to be 2.09. So I'm going to take just 2.09. So that gives it. Then the next question is asking you when. So one is you can do this way also, but you can also from the Desmos calculator, we can use make a function. So bt ph, sorry, equals 100 times 3 raised to the power h. And you can see, I want to know when is this going to be 1000. So I put y equals 1000. Okay, you can see and click on it and you get that 2.09 that we were talking about exactly. So one is you can graph and see the output when the output is 1000 and figure out from the graph, or you can use a calculator and check on which are the ones that gives you that answer. So I hope that takes care. So, but then there's one more question is asking when is the, so this question was when is this going to be 1000? The next question is asking is when is this going to be double? So let's see what that means. So the second part B says when is the for what input or after how many hours does the bacteria population doubles? So that means it is B of H is double means 200 because in the beginning it was 100, so it is when it's going to be 200. That means it double 100 times 100 goes it doubles. And you can see the factor is 2. So 100 times 2 is 200. So this is the growth factor, which is okay. So sorry. So you need to know 100 was the initial population. Then it is 3 raised to h, and we want to know when it is going to be 200. So 200 is, if you see the table that I made, is here. This is 200. So that means the population, the number of hours between 0 and 1. So we'll have to put 0 0.1, 0 0.2, 0 0.3 and check on when is this going to be 200, and you can use the same Desmos calculator here. So instead of this h here, we can put start with 0.1, 0.1. So it's 1, 1. So it's 111. Put 2, put 3, put 4, 5, 6, 7. Now if you put 7, it goes beyond 200. So I'll have to take off and put a 6, see? Or maybe 6, 5, or 6, 4, or 6, 3. I think that's perfect. So it is going to be 0.63. So that is 0.63. So let's go back here. So H is 0.63 hours. That's it. So this takes care of this task. The one that we were doing was, I think, yeah, it was lesson 8, and the task was the third one. So this is the 8.4 task, and you can see they give you the input is x and the output is 2 raised to x, so the base is the 2, and you're supposed to fill the blank spaces. So we'll start with the easy one here. So maybe let's see there is a 2 raised to 1. This means this answer should be 2 raised to 1, and 2 raised to 1 is 2. Okay. And then there is a 5 here. What does this mean? It is 2 raised to 5. It means 2 times 2 times 2 times 2. And you'll see you get 32. So this is 32. Now in between we have how many 2's do we multiply to get to 4? So what is that? 2 raised to 2 raised to what number? And you know it is 2 raised to 2 is 4. So this is 2. Now this 16 is 2 raised to 4 because 2 times 2 times 2 times 2 is 4. So this becomes 4. The question is, what is this? So, so how many 2's do we multiply here? And you can check. You will see it is 2 raised to 8 because 2 raised to 8 is 256, and this is 8, And then the question is, what is this? And you'll see you can check 2 raised to 10. So this is 10. Because 2 is multiplied 10 times, you end up getting 1000. So 2 raised to 10 is 1024. So this number is very important because it's like 1 gigabyte is 2000 2 raised to 10 megabyte. So this is megabyte, and 1 megabyte is 1000 2 raised to 10 bytes, and so on. Again, if you want to write 1 terabyte, then it is 2 raised to 10 gigabyte, and so on. So this number is very important. Now, go backwards. This is 2 raised to 0. Anything raised to 0 is 1. Now, this is 2 raised to minus 1. And this is same as opposite of this. See, 2 raised to 1 is 2. Then this side becomes half. So now this one is, of course, it is 1 over 2 square, which is can be written as 2 raised to minus 2. So this is minus 2. Now this is 1 over 2 raised to 5, which is same as 2 raised to minus 5. So this becomes minus 5. So the question is, what is this? And this is between 0 to 1. So this will be, so let's write it 2 raised to half. And 2 raised to half is square root of 2. So this is square root of 2. And this completes the whole thing. Let's see another one. Okay, this one is when input is x and it is 5 raised to x. So let's see how do we find. So this is, so what is this answer? So that the answer is given to you as 5. So it's like 5 raised to what number gives you 5? And the answer is has to be 1. So this is 1. And the next one, this one is what number is this, right? What input? That means 5 raised to, because this is the exponential function, 5 raised to what? How many 5s do we multiply to get to 125? And you can see it has to be 3 because 5 times 5 times 5 is 125. So this is 3. Then what about here? So 5 is to, how many 5s do we multiply to get to 625? And it has to be 3. So this has to be 4. So this becomes 4. And here, how many 5s do we multiply itself to give 3, 1, 2, 5? And that will be 5. We can always check this out, and it's true. Now let's go here, this piece. This is 5 is to what? Gives you 1, and you can see it has to be 0. So this becomes 0. Anything raised to 0 is 1. This is 5 raised to 1 over 5 raised to 1, which is 5 raised to minus 1. So this becomes minus 1. This is 1 over 5 squared, and you can use negative exponent property. This changes to minus 2. So this has to be minus 2. Now what about here, these two pieces? Let's do the 1/3. So when you put this one, so it is 5 raised to 1/3. You can write in the radical form as cube root of 5. So this becomes cube root of 5. And if it is 5 raised to 1/2, so it becomes square root of 5. So this becomes square root of 5. And that completes the thing. So all the tasks we finished 8.1, 8.2, 8.3, and 8.4. So now you're supposed to make sure you complete the packet. And also the next is the practice problem, so which already I uploaded in the Google Classroom. You kindly check. Thanks for watching.